99 million years ago, a fly got infected by something that should sound impossible: a zombie fungus. It lived during the age of dinosaurs, died, got sealed in amber, and stayed there until scientists found the fungus still bursting out of its head, which means nature invented zombies long before humans invented zombie movies. And the craziest part is that fungi like this still exist. Today, they infect insects, change how they move, make them climb, make them die in the perfect place, and then use the body to spread themselves again. This is the ancient version of what people now call zombie fungus. Not movie zombies, and not a virus sprinting through a city. It's something smaller and older, fungi that infect insects and turn the insect's final behavior into part of the fungal life cycle. The name sounds like clickbait, right up until you watch what the host actually does. The ancient clue belongs to paleontology, a preserved insect, frozen in amber, carrying evidence of a fungal infection from a world that no longer exists. But the behavior question belongs to the people studying living parasites today. They've spent years looking at zombie ant fungi, trying to work out how a fungus changes what an animal does. The fossil gives you the timescale, the living insects give you the mechanism. The question isn't whether a fungus can kill an insect. That part's easy. Nature kills insects constantly. The real question is stranger. How does a fungus with no brain, no eyes, and no map get a living animal to move to the right place at the right time and die in the right posture? That's the part scientists keep circling back to because it makes the host look less like a victim and more like a machine the parasite has learned how to operate. And this isn't one unlucky fly. Living examples show versions of the same broad pattern. Ants leave their normal routes and climb. Flies die in strange poses with their wings lifted. Cicadas infected by fungi keep moving while the fungus uses their bodies to spread spores. Different hosts, different fungi, but the same basic logic. The parasite doesn't just need a body to die, it needs the body to perform. For a zombie fungus, the forest isn't just background. The fungus has a practical problem because spores only spread under the right conditions, the right height off the ground, the right damp, the right warmth. The underside of a leaf or the stem of a plant can be the difference between a successful infection cycle and a dead end. So the host's final location becomes part of the fungus's anatomy. The insect isn't just infected inside its body, it's moved into position in the world. The cycle starts quietly. A spore reaches an insect and gets inside, and for a while the host still looks like itself. It walks on the trail, follows ordinary cues, and moves through the world as if the story is still about the insect. But underneath, the fungus is growing. The important part hasn't appeared yet. The zombie moment is still waiting. Then the host starts to do the wrong thing. An ant leaves the trail. A fly climbs upward. A body that should be hiding, feeding, mating, or avoiding danger instead moves toward a place that makes more sense for the fungus than for the animal. That's the first real zombie moment. Not death, but direction. The body's still alive, but the destination has changed. The ant becomes a climber. The fly becomes a pose. The cicada becomes a moving billboard for fungus. This is the part that makes the word zombie feel less like a metaphor. The host stays alive long enough to do something useful for the parasite, then dies in a way that's still useful for the parasite. Alive, it moves. Dead, it spreads. In these stories, the term that sticks is summiting. The host moves upward before it dies because the fungus doesn't just need a corpse, it needs elevation, airflow, humidity, and access to the next hosts below. Then comes the death grip, where the infected insect bites or locks into place, anchoring the body long enough for the fungus to grow. So the behavior isn't the whole story, it's the setup for reproduction. By the end, the insect is basically an NPC in its own body. Its legs are transportation, its jaws are a clamp, its corpse is scaffolding. The fungus doesn't have to build a tower from scratch because it grows one out of an animal that already came with legs. The image that sticks is the corpse tower, a fly or ant locked in place, fungus growing out of it, the dead body aimed at the living world below. The host is gone, but the body's still doing a job. That's the zombie part. Not walking forever, not chasing anyone, just being useful after the animal is no longer there. The finished product isn't a dead insect. The finished product is more fungus. The climb, the bite, the death, the growth out of the body, all of it points to the same end. Get spores into the world and find the next host. The zombie isn't the monster. The zombie is the delivery system. This is where the internet usually stops. Zombie fungus, mind control, nature is terrifying, roll credits. And to be fair, nature is terrifying. But mind control is also a shortcut, and it makes the fungus sound like a tiny villain with a plan, when the real story is stranger than that. So how does a fungus with no plan pull it off? Some zombie ant research suggests something even stranger. The fungus may not need to invade the brain like a pilot in a cockpit. It can spread through the body, wrap around muscle fibers, secrete compounds, and change the host's physiology in ways that shift behavior. That doesn't make it less creepy. It makes it more interesting, because the control might be distributed across the whole body instead of centralized in the brain. The hidden model isn't that a fungus thinks like an animal, it's that behavior can be an evolved interface. If a host has circuits for climbing, gripping, hiding, mating, feeding, or avoiding predators, then other organisms can evolve their way around those circuits. And here's the part that should bother you. It's not just a fungus we'd have to worry about. The most famous parasite behavior story of all, the one that reaches all the way to us, isn't a fungus at all. It's Toxoplasma gondii. Toxoplasma isn't a zombie fungus, and it doesn't prove that humans are puppets, but it's one of the best-known examples of the same host manipulation question. In rodents, Toxoplasma infection has been shown to change how they respond to cat odor, dialing down the fear that should keep them alive, which could plausibly make them easier for a cat to catch. And a cat is exactly where the parasite needs to end up, because that's the only place it can reproduce. Humans can be infected too, though the human side is messier. There are associations people argue about, and far less certainty than the rodent story. But the unsettling implication survives the caveat. A parasite doesn't have to control your thoughts to change how you move through the world. The amberfly doesn't prove that every modern zombie fungus behavior was already there 99 million years ago. And toxoplasmosis doesn't prove that humans are secretly controlled by cats. But together, they point at the same unsettling fact. Behavior isn't separate from biology. Long before humans invented zombies, evolution was already testing the machinery of movement, fear, attraction, and risk. Which is why, after learning all this, the cat in the corner looks exactly the same as it always did. You're the one looking at it differently.